Ports are great conduits for international trade and regional development. Approximately 90% of today's global trade relies on maritime transport. Although all sectors are racing forward toward Industry 4.0, it's anything but smooth sailing for the port sector. So what is holding the industry back? Insufficient workforce, rising energy costs, high operating expenditure, low efficiency, harsh working conditions, and potential security risks. Facing these mounting challenges, port operators are looking to turn the tide. Statistics show that about 75% of port operators believe that intelligence would make a significant difference to ports, and 65% expect operation security to be strengthened. So, how can these expectations become reality? The answer is 5G. As global ports evolve into the fifth generation, 5G has become the technology of choice to enable smart ports. Let's first take a look at the cargo unloading process to see how a port works. In the cargo handling area, container cranes move containers from vessels to inner container trucks. These trucks move the containers to the container yard, which is then unloaded by gantry cranes. Outer container trucks enter the container yard through gateways. Gantry cranes then load the containers onto these trucks, which exit through gateways, carrying the containers to the warehouses. As for container terminals, rail-mounted gantry and rubber-tired gantry cranes are the most common types of gantry cranes. A rail-mounted gantry crane moves along tracks in the container yard, while a rubber-tired gantry crane can flexibly move containers across yards. Communication in ports is primarily guaranteed by optical fibers and Wi-Fi. For instance, automated driving of gantry cranes is controlled from the operator's cab through Wi-Fi. Well, what is the biggest challenge facing today's port operations? Efficiency. Efficiency is paramount for port operations. Large vessel rentals are expensive. Just an extra hour of waiting or work can cost tens of thousands of RMB. Therefore, ports need to ensure they can sustain 24/7 uninterrupted operations year-round. If the customers suffer a loss due to low efficiency, they may never return. The key to efficiency lies in the container yard and the container crane area. So, what exactly is holding back the efficiency? First is safety risks. The height of the container crane is 60 to 70 meters tall, posing significant safety risks. Working conditions in the operator's cabs are rough, where operators are prone to fatigue. Second is labor cost. A large number of crane operators are required in order to ensure 24-hour uninterrupted operations. Every container crane is overseen by 3 operators in rotation. Hiring and training these operators is also extremely challenging. Third is networks. Cable networks does not work well in the container yards due to the need for cranes to be mobile. In addition, cable maintenance is costly, because cables are prone to damage in seaside environments. Wi-Fi technology, as an alternative, has poor coverage, weak network security and reliability, and may cause communication delays, making it unfit for various equipment that requires high precision. To overcome these challenges, port operators are requesting to upgrade to smart ports that offer automated operations and enable unattended sites. Then, what are the key requirements of a smart port? Based on the requirement survey and discussions and analyses with our port industry partners, we have identified the following key requirements. First, remote control of the container cranes to load and unload containers, and detection of vessel docking. Second, remote control of the gantry cranes to load and unload containers, automated driving of gantry cranes, and intelligent cargo transit across yards. Third, IGV control of inner trucks to enable unmanned driving and automated retreat once a faulty occurs. Last, automated guidance for the docking of vessels by the guidance ship, automated inspection by drones and robots to enable real-time monitoring as a security measure. To meet all the above requirements, what are the demands on the bandwidth, reliability, and latency of the communications network? Analysis indicates that remote video monitoring requires a bandwidth of 100 Mbps. Remote control and automated driving of inner trunks demands a reliability of up to 5 nines, and the network latency must be less than 30 millimeters. Taking all these requirements and the differences among different network solutions into consideration, 5G network is the most suitable for the job. 5G not only solves problems related to construction, maintenance, planning, and coverage, but is also resistant against interference from communication signals, equipment activity, and environmental factors. Moreover, by deploying the UEG at the 5G network edge or near the ports to power MEC, ports can benefit from low latency, high reliability, and data processing within the campus. Therefore, port operators prefer to use 5G plus MEC to build 5th generation smart ports. To conclude, let's see how 5G plus MEC powers smart ports. The equipment is upgraded to ones with 5G capabilities, with 5G modules or customer premises equipment, or CPE. Operators deploy 5G base stations and MEC at ports and plan different network slices based on services to meet the network requirements of different services and applications. After MEC is deployed, the 5G core delivers the local breakout policy to the MEC server to route port services to the local server for processing. When a smart port device is in operation, it establishes a communication connection with the 5G base station through the network slice. The 5G base station routes the port service to the MEC server, which then routes the service to the local server for processing. The processing by the local server and the differentiated network slicing together ensure low latency, robust reliability, and high bandwidth for communications, and guaranteed data processing within the campus. What other benefits does a smart port bring? In terms of labor cost, it is significantly reduced. Whereas each container crane requires 3 operators to work in rotation to ensure 24-hour uninterrupted operations before, 1 operator with remote control is enough to operate 3 to 6 gantry cranes at the same time now. Suppose there are 100 gantry cranes, the number of personnel needed will be reduced from 300 to 75. And the labor cost is reduced from 33% to 10%. And operators no longer need to work so high up. To sum up, the working environment and efficiency have both improved drastically. Material cost is also brought down. Previously, the cables need to be replaced every 2 years due to the seaside environment and equipment activity. After 5G network communication is used, the operation expenditure for each crane will be reduced by roughly 500,000 RMB a year. Wireless networks and automation also improve the efficiency of cross-yard transit of gantry cranes. Assume that efficiency is improved by 25%, 1/5 of gantry cranes can be reduced. Additionally, the MEC Edge Node UEG provides service governance capabilities for apps. By building a port service application ecosystem, that is, deploying apps on the UEG, a range of new services including smart gate, remote scheduling, and smart tallying can be implemented.